Hello everyone, I am Melani Putri Hasiana from Mathematics Education from Jakarta State University. This video is my final project of English Math. In this video, I will talk about Euler's number. The number e is one of the most important numbers in mathematics. The first few digits are 2.71882845904523602874712527 and more. So, what is E? E is an irrational number, so it cannot be written as a simple fraction. E is a transcendental number. E is the base of the natural logarithm, and E is found in many interesting areas, so it's worth learning about. Next, how to calculate the value of E. There are many ways of calculating the value of E, but none of them ever give a totally exact answer because E is irrational and its digits go on forever without repeating. But it is known to over 1 trillion digits of accuracy. For example, the value of 1 plus 1 over n to the power of n approaches E as n gets bigger and bigger. You can look at this table and this graph. There are another calculation to calculate the value of E. The value of E is also equal to 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, etc. And the first few terms add up to 1 plus 1 plus 1 over 2 plus 1 over 6 plus 1 over 24 plus 1 over 120 equals to 2.71666, etc. In fact, Euler himself used this method to calculate E to 18 decimal places. And here is E to 100 decimal digits. Next is about how to remember the value of E. To remember the value of E to 10 places, just remember the saying. You can count the letters and you can remember the value of E. The letters is to express E. Remember to memorize a sentence to memorize this. Or you can remember the curious pattern that after the 2.7, the number 1828 appears twice. And following that are the digits of the angles 45 degrees, 90 degrees, 45 degrees in a right angled isosceles triangle, 2.71828 1828459045. This is an instant way to seem really smart. Next is about growth. E is used in the natural exponential function. it has this wonderful property. Its slope is its value. At any point, the slope of e to the power of x equals to the value of e to the power of x. When x is 0, the value e to the power of x is 1 and the slope is 1. When x is 1, the value e to the power of x is e and the slope is e, and etc. Next is about area. The area up to any x value is also equal to e to the power of x. Next, use of E in compound interest. Imagine a wonderful bank that pays 100% interest. In 1 year, you could turn $1,000 into $2,000. Now imagine the bank pays twice a year, that is 50% and 50%. Halfway through the year, you have $1,500. You reinvest for the rest of the year and your $1,500 goes to $2,250. So, could we get even more if we broke the year up into months? We can use this formula 1 plus r over n to the power of n, with r is annual interest rate, n is number of periods within the year. Our half-yearly example is 1 plus 1 over 2 to the power of 2 equals to 2.25. And let's try it monthly. 1 plus 1 over 12 to the power of 12 equals to 2.613. And let's try it monthly. 1 plus 1 over 10,000 to the power of 10,000 equals to 2.718. Why does that happen? Because the compounding formula is very like the formula for E as n approaches infinity, just with an extra r, the interest rate. When we choose an interest rate of 100%, the formulas became the same. So next is Euler's formula for complex numbers. We can use this formula for complex numbers. E to the power of IP plus 1 equals 0, with E is Euler's number, I is the unit imaginary number, and P is the famous number P that turns up in many interesting areas, and 1 is the first counting numbers. Last is about E-Day. So you can celebrate E-Day on 27th January at 28 past 8, or you can celebrate it on 7th February at 28 past 18, and of course you can celebrate E-Day on both days. So that's all from my explanation about Euler's numbers. I'm sorry if there are any mistakes that I made, and thank you for your attention.